Hello, this is parent functions and transformations. We're going to be talking about all the different shapes parent functions take and then the transformations we can graph from those parent functions. Here are our objectives. We're going to identify many different kinds of graphs. We're going to identify linear and squaring functions, cubic, square root, reciprocal functions. Just by looking at the graphs, we're going to talk about step and piecewise defined functions. We're also going to talk then about vertical and horizontal shifts, using reflections to sketch graphs of functions, and non-rigid transformations. And we're even going to talk about what the heck that means. Alright, linear and squaring functions. Linear functions, that's easy. It's a line. You know that. That's our y equal mx plus b, where m is the slope and b is the y-intercept. We have quadratic functions. You've used those a number of times. Those are parabolas. When it's a y equals something with an x squared, it either opens up or it opens down, depending on the leading coefficient, which is a, and the trailing constant, which is c. We set it equal to 0 and factor. That finds us the zeros of the function. Here we have a cubic function. Notice the two different turns, the 3 zeros. Okay, this is all part of cubic functions. It's going to have 3 zeros, 1, 2, 3, and 2 turns. There we go. Square root function starts at one point and goes. Now, if we did a plus or minus in front of that square root, we'd get the other half of that parabola. Yep. Wow, I get lots of colors to choose from. I'm going to... I have no idea what that means. Okay. There we go. Alright. We also have reciprocal functions. Let's see. Oh, yep, I am purple. I'm not blue anymore, I'm purple. Alright, a reciprocal meaning that there is an x in the denominator. This is also called a rational function. This is where we get our asymptotes, right? This one has an asymptote of x equals 0 and y equals 0. Next, we're talking about the step functions. Oops, I just drew accidentally with my finger. I was trying... Oop, I didn't want to change the color. Okay. To move the slide, but it didn't work. Step and otherwise piece-defined functions. A piecewise function means it's broken into pieces. Notice this one. Now, this is an odd-looking little symbol, the double bracket. This means the integer, the largest integer, less than the number. So, if I have 2.3, oops, there's a point in there. 2.3, the largest number less than 2.3, oops, I have to have an extra bar there, is 2. If I have 3.8, the largest integer less... Oh, sorry. Alright, these are different functions that we have. Okay, these are the different parent functions. We have a sine function, cubic, quadratic, linear. You know what that is. This one over here is a cosine function, rational, exponential, and logarithmic. You've seen all of these, so you should be familiar with them from Algebra 2. I want you to do your in-class worksheet right now. I'm going to pause this, and then I will talk you through that. Hang on.